This project is the Urchin brush and is sponsored by Justin Avanias. Justin has his own sailboat and while out with his family and friends realized that the boat can get very dirty from algae and other substances in the water, which then reduces the speed and travel distance of the boat. He wanted to create a device that would allow him to stand on top of his boat and reach all parts of the hull to clean it. He has had one group design a drill-powered brush and has tasked us with making a battery-powered brush. The problem Justin faced was the cost of cleaning a sailboat. He didn't want to buy dive gear and expensive tooling or spend extra time and money taking the boat out of the water after each use with his family to clean it. This device that we would be creating would reach 12 to 16 feet in length. The device would be easy to extend and retract. It would be safe to use, and it needed a way to keep the brush against the boat underwater. As we began building our device, there were three areas of focus: the housing for the motor and pump, the housing for the battery and where to run the wires, and the connection between each section of pipe. The top left and bottom right images show how we took our pipe, cut holes into it, and inserted a spring pin in for easy connect and disconnect. The center image shows a gearbox connected to the motor so we could have two brushes on each side of the housing for better cleaning. The bottom left image was our initial design of the housing, but was later changed. The top two images show the changes that were made to the battery and switch housing over the course of the project. The bottom left image is an example of the curved pole we created, and the bottom right is an updated and final design of our housing for the pump and motor. Everything came together to show a device that was compactable as shown in the top right image, but also extendable as shown in the center image. One major test that needed to be done was to see if this was waterproof, and is shown here. The test proved that our device was waterproof and that the pump worked as intended and pushed it against the surface. The results of our testing confirmed all of the requirements we had for the device. It reached 12 feet 9 inches, was battery operated, was safe for the user, and easy to connect and disconnect, and most importantly was waterproof. Going forward, we have suggested a few things to our sponsor, mainly a telescoping tube, custom brushes that he is currently working with a manufacturer on, and a better battery pack that would integrate better with the tubing. The other main thing would be injection molded parts as we 3D printed ours. Overall, we were very happy with the device and glad to have been working on this project this semester.